Once again we are back with new topic, acceleration. So guys, in my previous video I have discussed up to velocity. Okay, velocity. The definition of velocity is what? The rate of change of position. Okay, the rate of change of position is known as velocity. The rate of change of position is known as velocity. Means what? Which I have already told you. Delta means the change in. Okay, delta means the change in. If it comes along with position, then it will be the change in position. Okay, the change in position. If delta is along with velocity, then it will be the change in velocity. Okay, and if it comes along with acceleration, then it will be the change in acceleration. The change in means what? The change in means the position is changing. There will be two positions. Okay, one will be final position and another one will be initial position. Okay, delta means there will be two things, one will be final, another will be initial. What is initial and what is final position? Okay, when the motion start from this point A and the body reach finally at point B. Okay, then this point A is called initial position and the point B is called final position. Okay, and delta x mean what? Delta x means final position minus initial position. Always we will subtract initial position from final, then it is called delta x. In same way, in the case of delta v, it will be equals to final velocity minus initial velocity. Okay, if initial velocity is u and final velocity is v, then in this case delta v will be equals to v minus u. Okay, sorry, delta v will be equals to v minus u. So, and delta x upon delta t mean what? The rate of change, means delta t represents time. Okay, now acceleration. What do you mean by acceleration? In simple definition we can say the rate of change of velocity. Okay, the rate of change of velocity. The rate of change of velocity is known as acceleration. Okay, the rate of change of velocity is known as acceleration. Means if a body is changing its velocity, okay, if a body is moving with variable velocity, then there will be acceleration. Let us suppose a body starts motion with velocity u and finally its velocity becomes v. So in this case acceleration will be equals to v minus u upon t. Okay, here the value of a will be equals to v minus u upon t. What is v? This is final velocity, u is initial velocity, and here t is time taken by the body, okay, to reach from A to B. So in this case acceleration is equals to v minus u upon t. Let us suppose the initial speed of body is v naught and final speed is v. In this case we can write acceleration will be equals to v minus v naught upon t. Okay, let us suppose the body is moving from v1 initial velocity and v2 is its final velocity. When the motion is starting here, then here time is t1 and at point B the time is t2. Then in this case acceleration can be right here v2 minus v1 upon t2 minus t1. What is the meaning of this? It is equals to delta v upon delta t. In same as in the case of velocity, x2 minus x1 upon t2 minus t1. Okay, so we can say acceleration is what? The rate of change of velocity is known as acceleration. There are two types of acceleration. There are two types of acceleration. One is uniform acceleration. Uniform acceleration. or we can say constant acceleration. Okay, constant acceleration. First one is uniform acceleration or constant acceleration. In next step, second one is non-uniform acceleration. Okay, non-uniform acceleration or variable acceleration. Okay, what do you mean by uniform acceleration? Means here acceleration is constant. Okay, acceleration is constant. Mean what? Why acceleration will be constant? If the body is increasing its velocity in same rate. Okay, let us suppose at point A the velocity of the body is 2 meter per second. At point B its velocity is 4 meter per second. At point C its velocity is 6 meter per second. At point D its velocity is 8 meter per second. In every second the body is increasing 2 meter per second its velocity. Okay, in every second. In first second its velocity is 2 meter per second. After 1 second its velocity 4 meter per second. In next second its velocity is 6 meter per second, and again 8 meter per second. Means what? Its velocity is increasing with constant rate. So we can say that here the acceleration will be constant. How can you say the acceleration will be constant here? Friends, as we know, acceleration is equals to v minus u upon t. Here between A and B, in position A and B, the final velocity is 4 and the initial velocity is 2 meter per second. The time taken is 1 second. So here the acceleration will be 2 meter per second square. Okay. In between point B and C, we can say in between point B and C, the acceleration will be equals to 6 minus 4 meter per second, and the time taken is 1 second, because the time taken to reach from B to C is 1 second. Here is also 1 second, here is also 1 second, here also 1 second. Okay. So in this case also acceleration will be equals to 2 meter per second square. In the same way, when body reach from C to D, then in this case its final velocity will be 8 meter per second and initial velocity will be 6 meter per second. Okay. So here acceleration can be right 8 minus 6 divided by 1, because here time taken is 1 second. So here will be 2 meter per second square. Okay. So when body change its speed with constant rate, okay, then the acceleration is called uniform acceleration. See here, in each and every cases the acceleration of the body is 2 meter per second square. So when the body increase its velocity with same rate, then in that case the acceleration will be uniform acceleration. Then what do you mean by non-uniform acceleration? If a body is moving with 2 meter per second speed, in next second its speed becomes 5 meter per second. In next step its speed becomes 6 meter per second. In another step its velocity becomes 10 meter per second. Okay. Then in this case the increasing of velocity is not with a constant rate. Okay. Because here acceleration will be equals to 5 minus 2 upon 1, because in between A and B, here at point A the velocity is 2 meter per second and at point B the velocity is 5 meter per second. So 5 minus 2 upon 1 means it will be equals to 3 meter per second square. Here the acceleration becomes 3 meter per second square. In next case, between B and C, the acceleration can be right here 6 meter per second is final velocity between these 2 points only. Okay. Final velocity is 6 meter per second and initial velocity is 5 meter per second. So 6 minus 5 upon 1, it will be equals to 1 meter per second square. Okay, so you can compare these two equations. Here 1 meter per second square, and here the velocity will be in between 5 and 2, the velocity will be 3 meter per second square, because in between A and B acceleration will be right. 5 minus 2 upon 1 means it will equals to 3 meter per second square. So on comparing these two equations, we can say here acceleration is not constant. Okay, and if the acceleration will not be constant, then that type of acceleration is called non-uniform acceleration. Now first one more thing I just want to discuss: average velocity. Average velocity, it is equals to initial velocity plus final velocity divided by 2. Okay, or you can say u plus v divided by 2. Here u is initial velocity, v is final velocity, and upon 2, and the average velocity will be represented by v vector or v bar, you can say v bar. Okay, this is the representation of average velocity. From using this equation, we will derive the equations of motion. So guys, we are going to derive the three equations of motion. There are three equations of motion, from which we will solve the numericals related to this chapter. First equation will be v is equals to u plus at. Okay, v is equals to u plus at. This will be the first equation of motion. Second, s is equals to ut plus half at square. Okay, s is equals to ut plus half at square. And third equation is v square is equals to u square plus 2as. In these three equations, we can see here, in the case of first equation, here final velocity is given, initial velocity is given, uniform acceleration is given, and time taken is given. Okay, so here absence of only distance. Okay, not distance, it's displacement. Okay, so here displacement is not given. In second equation, final velocity is not given, and in third equation, time taken is not given. Okay, so according to the situation, we will use these three equations. First equation, v is equals to u plus at. Second equation is s is equals to ut plus half at square, and third equation, v square is equals to u square plus 2as. Okay, now we are going to derive the derivation of these three equations, which are very important for our examination point of view. Okay, so first equation, v is equals to u plus at. See here, as we know that acceleration is what? The rate of change of velocity. Okay, the rate of change of velocity is known as acceleration. So Here we can write v minus u divided by t. Why I am writing here t? Because if the body start motion from point A and it reached at point B, okay, so here the motion is starting, so initial velocity will be u, and at time t is equals to 0. At time t it reached at point B with final velocity v. Okay, so in this case t2 minus t1, so at the place of t2 we will write t, and at the place of t1 we will write 0. So t2 minus t1 will be equals to t, and here t will comes here, and it will equals to at is equals to v minus u. Okay, when u will taken in this side, then v will equals to u plus at, and this is called first equation of motion. Now I am going to derive second equation of motion, s is equals to ut plus half at square. As we know that average velocity will be equals to u plus v divided by 2. Okay, and here we can write displacement will equal to average velocity multiplied by time taken. Okay, here average velocity into time taken is called displacement. So s can be right here. At the place of v bar we can put the value of it, u plus v divided by 2 into t. Okay, now from first equation of motion we can write at the place of v is equals to u plus at. So at the place of v we can put the value of it, and we will get s is equals to u plus, at the place of v the value of v is what? U plus at. So at the place of v we can write u plus at, and it will equals to u plus at. Okay, upon 2 into time taken. Now s is equals to u plus u means 2u. Okay, u plus u, 2u plus at upon 2 multiplied by t. Okay, now we will multiply this t in u and at, so we will get s is equals to 2ut plus at square and whole divided by 2, because when t will multiplied in u, then we will get 2ut, and when it is multiplied here, so a t into t means t square. So s is equals to 2ut upon 2 plus at square upon 2. We are writing it separately, and 2 will cancel out, so we will get s is equals to ut plus half at square. Okay, this is our second equation of motion which is proved here. S is equals to ut plus half at square. Now we are going to derive the third equation of motion. V square is equals to u square plus 2as. Okay, so see here, you can pause the video and note it down. Now third equation of motion is what? V square is equals to u square plus 2as is going to deriving here. Third equation of motion, v square is equals to u square plus 2as. As we know that s is equals to v bar into t. V bar is average velocity and t is time taken. Okay, so displacement can be right here, average velocity multiplied by time taken. At the place of v bar means average velocity, we can write the value of it u plus v divided by 2. just as second equation. So s is equals to u plus v upon 2 into t. Okay, now from first equation v is equals to u plus at, we can write the value of t here. From this equation we can write t is equals to v minus u divided by a. This will be the value of t, because a is equals to v minus u upon t. So at the place of t we can write it value v minus u upon a. So here s will be equals to v plus u upon 2. In another bracket we can write v minus u upon a, because at the place of t we have write the value of t here. Now we can see one equation is given here, a plus b, a minus b. Okay, because at the place of a here v is given, and at the place of b u is given. So v plus u, v minus u, and as we know a plus b, a minus b will be equals to a square minus b square. So at this place also we can write s is equals to v square minus u square divided by 2 into a, means 2a. Now we will get 2 will comes in this side, then 2as will equal to v square minus u square. Okay, when u will comes in this side, so v square will equal to u square plus 2as. Okay, this is called third equation of motion, and these three equations are most important factor of this chapter. First equation v square v is equals to u plus at. Second, s is equals to ut plus half at square. And third equation v square is equals to u square plus 2as. Okay, and these equations will use to solve the numericals related to this chapter. Okay, according to the situation. And situation is what? In first equation s means displacement is not given. In second equation final velocity is not given, and in third equation time taken is not given. So according to the situation we will use this equation to solve the numericals. Now we will derive it from the graphical method, which is a part of our NCERT and also in our syllabus. These three equations can be derived by graphical method also. Before to derive these equations, I just want to say something about graph. Let us suppose a distance time graph. Okay, distance time graph, distance time graph. It gives speed. Okay, the distance time graph gives speed. The slope of this distance time graph gives speed. The slope of a displacement time graph, gives velocity. Okay, velocity. If the displacement time graph is given in this way, so here the motion is non-uniform motion, and if it is in straight line, so we can say here the motion is uniform motion and here non-uniform motion. Okay, so in the case of uniform motion acceleration will be equal to 0, and in the case of non-uniform motion there will be some acceleration. Okay, there will be some acceleration. In same way, velocity time graph gives acceleration. Okay, see here, if it is a velocity time graph So the slope of it give acceleration, okay, acceleration, and here the acceleration will be constant, which is called uniform acceleration, okay, because here velocity is increasing with constant rate. So the graph of this velocity time graph is in a straight line, okay, and if its graph is in this way, the velocity time graph is given in this way. So here acceleration will be variable, okay, and here the velocity will be non-uniform velocity. Here the velocity is uniform velocity, and in this case the velocity is non-uniform velocity, and in the case of non-uniform velocity the acceleration is variable here. Now we will use this velocity time graph to derive the equations v is equals to u plus at, and s is equals to ut plus half at square, and v square is equals to u square plus 2as. Let us suppose a graph which is velocity time graph, velocity time graph, okay. If a body start motion from this point called A and it reached at point B, okay, here the starting velocity of it is u and its final velocity is v, okay, at time t. So after taking time t, it reaches at position B. This point is called O, this D, and this is called C, okay. Now from the help of this graph we will derive the equation of motion. So if I ask you what will be the value of C and E, you can see from O to B the distance is V, okay, from O to B the distance is V, and from O to A the distance is U. So from C to E the distance becomes V minus U, okay, here the distance becomes V minus U. As we know, the slope of this graph gives the value of acceleration because it is a velocity time graph, and the slope of velocity time graph gives the value of acceleration. So here acceleration can be right, acceleration is equals to slope of graph, and slope is equals to tan theta. Tan theta means perpendicular upon base, okay. Tan theta means what? Perpendicular upon base. So here perpendicular, the value of perpendicular is CE upon base is what? AE, okay, AE. So at the place of CE we can write the value of it, which is V minus U, and at the place of AE we can write the value of it, which is T, okay. So it can be right here T. From this value we will bring this T in next side, so it will equals to AT. AT will be right here, AT is equals to V minus U, and we will get V is equals to U plus AT. This is our first equation of motion. In next step, what is second equation of motion? S is equals to ut plus half at square, okay. S is equals to ut plus half at square. This is our second equation of motion. How can we derive the value of it? One thing is clear, the velocity time graph slope will always give the value of acceleration, and its area will give the value of displacement, okay. This area will give the value of displacement, okay. So displacement can be right here, displacement can be right here, area of trapezium A, O, D and C. Okay, area of A, O, D and C will give the value of displacement. So area of A, O, D and C. Now at the place of displacement we can write S. So here S will be equals to area of triangle AEC plus area of rectangle AODE, then AODE. Okay, because when we add the area of this rectangle and this triangle, then we will get the whole area of this trapezium. So S can be right here. S is equals to area of triangle AEC. It will equals to half into perpendicular into base. Okay, so at the place of perpendicular we can write CE, then here will be CE into what is base AE, then here AE plus area of AOD. It can be right length into breadth. So at the place of length we can write T, and at the place of breadth we can write U. So it will equals to AO into OD. Okay, so here we will get S is equals to half at the place of CE V minus U, and at the place of AE it is equals to T plus U into T. Okay, because the value of AO is U and the value of OD is T, so S is equals to UT plus half AT square. How can we write it from this value? You can see here A is equals to V minus U upon T. So at the place of V minus U we can write AT. Okay, AT. So when we write here AT, then half AT into T means half AT square. So S is equals to UT plus half AT square. This will be the second equation of motion, which is derived here from graphical method. Okay. Now third equation of motion. What is the third equation of motion? That is V square minus U square is equals to 2AS, or we can write V square is equals to U square plus 2AS. Now this equation will be going to derive here. Okay. In same way, as we know, displacement can be right here. Area of this trapezium AODC. So area of trapezium AOD and C. Okay. As we know, area of trapezium is what? 1 upon 2 into sum of parallel sides. So here sum of parallel sides is AO plus CD. Okay. So AO plus CD into sum of parallel side multiplied by height, and here the height is OD. So here height is OD. Okay. Now S is equals to half at the place of AO. We can write the value of it, which is U, plus at the place of CD, the value of CD is V. So U plus V into what is the value of OD? It is T. As we know, in third equation of motion the time is option. Okay, in third equation of motion time is not given, but here is time. So at the place of t, we can write the value of it. As we know, a is equals to v minus u upon t. So from this equation, we can write t equal to v minus u upon a. Now at the place of t, we will put this value, v minus u upon a, and we will get s is equals to v plus u upon 2. In another bracket, at the place of t, we can write v minus u upon a. Okay. Now once again, we can see here a plus b, a minus v. Okay, this equation is given here, v plus u, v minus u. Okay, and as we know, the value of it is a square minus b square. Okay, so here also we can write v square minus u square upon 2a. Now 2a will bring in next side, and we will get and here we will get 2as. Okay, so it will equals to 2as will be equals to v square minus u square. So here v square minus u square. Now we can write v square is equals to u square plus 2as. This equation is called third equation of motion. So from graphical method, we have derived these three equations: v is equals to u plus at, s is equals to ut plus half at square, and v square is equals to u square plus 2as. The last topic of this chapter is circular motion, uniform circular motion, uniform circular motion. What is uniform circular motion? If a body is moving in a circular track, okay, if the body is moving in a circular track with uniform velocity or with uniform speed, so that motion is called uniform circular motion. See here, uniform means constant, circular means in a circular track, motion means motion. Means if a body is moving in a circular track with uniform speed, then that motion is called uniform circular motion. In this case, in one complete revolution, the body covers 2 pi r distance. Okay, if the radius of this circular track is r. Okay, if a body A starts motion from this point, and after one revolution it reached at that point, okay, in that case total distance traveled by this body will be equals to 2 pi r. And what will be displacement? Displacement will be equals to 0. After one revolution, displacement will be equals to 0. After one complete revolution, or 2 complete revolution, 3 complete revolution, 100 complete revolution, means in complete revolution the displacement by the body in a circular track will be always equals to 0. But here distance traveled is 2 pi r. After 2 complete revolution, 4 pi r. 3 complete revolution, 6 pi r. Okay. If a body is moving in half circular track, let us suppose this is point A and this is B. This is half circular track and its radius is r. Okay. In this case, the distance traveled by the body, okay, total distance traveled by the body will be equals to 2 pi r divided by 2. Okay, because body is moving from A to B from this circular track only. Okay, so in that case, distance will be equals to 2 pi r divided by 2, because 2 pi r is the circumference of the circle. So here 2 will be cancelled out and we will get pi r. It will be the distance traveled by the body. So what is displacement here? Here displacement can be write it is the smallest distance between two positions. So smallest distance between these two positions A and B is equals to r plus r, okay, which is called 2r. So here displacement will be equals to 2r, okay. After completing this topic, we have completed this chapter, okay. Thank you guys.